Testing. Testing. 1, 2, 3, 4. Quite fast. 1 to 2 second delay. Can you hear? Yep. So I try to use the YouTube for this second part lecture. I hope it's working. Yeah, so all this video will be recorded in the in YouTube, and I will put it there so you can watch it. Yeah, so you can put if you can't hear or whatever, you have any question, you can try to post your question in the chat, in the live chat. But there's some delay. I hope you can understand. YouTube definitely will put some delay. Maybe I estimate today is about 3 seconds. Sometimes maybe longer, depend the bandwidth, the network. So yeah, I already trying to use the ultra low latency. So but no matter how, you still have 3 second to 15 second delay. Well, right now we have 42 viewers. Wow, we have 600 plus students. Only 42 students attend. Okay. So today I will just give you a short introduction about, give you an overview about the second part of this CX1107, and then we'll talk about, hopefully maybe today or Wednesday 4:30 to 5:30, I will give another lecture about the analysis of algorithm. Yeah, so yeah, that's what we're going to cover this week. Yep, so that is the learning outcome of this module. You suppose at this stage, next week we're going to, next week is the recess week, going to have the first lab test. First lab test. Should be lab test. Typo. Then to cover everything you have learned so far about the different data structure from linked list, stack and cube, binary search, binary tree, binary search tree. In the first half covered by Dr. Owen. And second part after, so I trying to cover the second part this week, mainly because this analysis of algorithm is about a lot about the mathematics stuff. Algorithm may not be something what you talk about, that it's just programming. It's not true. So you need to prepare some mathematics. Especially in the week 14, we're going to have a quiz, which is 20% for the final quiz. You'll cover all this concept theory. You learn in the first part and second part. Quiz is MCQ, but we will test you all the concept. That is not programming. Okay, so analysis of algorithm. Obviously you will find that it's everything about mathematics. So I cover today so that if you are not good in mathematics, you still can trying to catch up during the recess week. In fact, before that, I already tried to upload the mathematics revision for you, so that you have over the 6-7 week to trying to recall all the mathematics you have learned in your high school. So this is what you need to be able to select the appropriate data structure. And of course, you need to be able to implement, realize the algorithm you have learned to solve some maybe real world, maybe some simple real world problem. I have to say it's a simple real world problem because a lot of real world problem is much more complicated than what you are doing in the lab in the assignment. Okay, so this part will be learn it in the lab section in the assignment. Yeah, so lecture I won't show the code, so you will find that I purposely try not to write now the C programming code in the lecture notes because I want you yourself to realize it by your own. Yeah, maybe I give you the algorithm. You need to know how to write it into a C programming code and run it in the program and run it correctly. Yeah. Then and also maybe sometimes I maybe just give you an idea, rough idea, about this algorithm. Then you need to go and sort out the algorithm and implement it by your own. Yeah, that is what actually you need to practice. Okay, and another thing you need to learn is conduct the complexity analysis of the algorithm. In this level, we don't expect you really can come out the best algorithm. Mainly is we give you the problem, you just need to know how to solve it by you writing a program. Come out the algorithm, then implement it, realize it into a C program, and then solve the problem. The algorithm, as long as you can solve it, maybe the algorithm is not the so-called best algorithm. Yeah, the complexity is not the best time complexity. At this stage, it's still acceptable. Yeah, so you just need to know how to analyze. At least you need to know, okay, your algorithm is not good, but what is the complexity of your algorithm? Or we give you some algorithm, you need to know that their complexity. Yeah, you need to be able to analyze the complexity, but you may not need to be able to come out the best solution. Yeah, you just need to know that algorithm A is better than algorithm B in their time complexity. Yeah, you are able to compare, you are able to analyze them. That should be good enough for this level. But in the next level, you may need to be able to find out what is the best algorithm. Yeah, in level 2000. So in part 2, we have the final quiz 20% I've mentioned. We have another lab test 2 in week 14 also at the same times. Yeah, so details I will let you know after you finish your lab test 1. Yeah, then we also have 4 assignment. Forgot to change. Should be 4 assignment. Yeah, if time allowed, I should try to make it 4 assignment. Okay, so should be 4 assignment. Yeah, so from week 10, so you have, after the recess week, you have 2 week break. Yeah, then they have an assignment weekly till week 13. I trying to finish the material by week 12, so that then tutorial will be again same as part 1. We only have this week no tutorial. This week no more tutorial, so we only have 3 tutorial. So first part have 3 tutorial, then second part have 3 tutorial. So tutorial is help you, my part is more on let you understand the concept. Yeah, so programming is in the lab. We have 4 lab section for the programming. Then tutorial sometimes also can let you have a chance to have some tutor help you to clarify your doubt in the lab or tutorial question and so on and so forth. Yeah, so these are the time schedule. Yeah, for the second part. And the assessment 20%, assignment 20%, meaning 5% for each assignment. Yeah, I have to take notes. Plagiarism is a serious academic offense. Please don't try to copy the code. It's not really help you, because in the lab test you also won't be able to do anything if you copy all the assignment from your friend. So if you get caught by the system, detect that you are copying your answer from your friends or your friend copy your answer, basically we wouldn't go and analyze who copy whose. We just simply give both 0. Sometimes give whole group 0. Yeah, because one person share out the code to everyone. Then he think that he very kind. So consequence is everyone will get 0. Yeah, sometimes, yeah, it's not you sharing the code, you are helping your friend. You just trying not to let them have chance to learn. So just take notes. Yeah, so basically this module you can see that is one of the important prerequisite of many 2000 module, from algorithm design analysis, introduction to database, and so on and so forth. All need you to pass this module. And basically you can see after you learn the computational thinking, so data structure is one path. So this is more on the theory part. Or you can think, it's algorithm design and analysis, artificial intelligence, a lot of mathematics maybe. Yeah. So the other path is the OODP, or object-oriented design programming, software engineering. Yeah, this is how you implement, how you design the program, the software program. Yeah. So if you're talking about implementation, actually this path is more on the implementation, more on the coding, programming. So this path is more on the concept. We will focus more on the concept. Doesn't mean you don't need to program. It's just we assume that you already learned all this module. Yeah, we wouldn't go repeatedly tell you how to code the program. No. Yeah. So of course you can see the prerequisite for this module. We also require you to pass the discrete mathematics for the 2101. And this one will cover some basic analysis. So unavoidable, I also need to use some mathematics. But I try not to cover too advanced mathematics content, which require the discrete mathematics. But you need to prepare that, these things, all this you need to learn, you need to use them in 2101. Yeah. So on the other hand, data structure also is a prerequisite of some CE module. Yeah. So after you have learned 1106, 1107, there's a prerequisite for your OS. These two modules. Because when you handling OS, is talking about something like multitasking or this parallel programming stuff, maybe. Yeah. So if you not even know how to write a simple program, not surprising, you also don't know how to write multitasking program. Yeah. So here, just give you an overview about what is an algorithm in the next few slides, and some typical problem type in computing, but not all of them. I only just roughly give you some brief idea, and then some algorithm design strategy you commonly heard about. Briefly tell you. We will cover this material in the next few weeks lecture. I would say that it's briefly because this is an introduction module. Yeah. So if you simply Google search, what is algorithm? Actually, I just made a Google search yesterday. In fact, you look at the usage of algorithm is since 1950. Algorithm a lot of people start use this word. And actually that is the reason is because when we start having around 1958, we have the first computer invented. So after that, people start to develop a lot of new algorithm. Because computer is very good in solving this kind very repeatedly tedious job for us. But doesn't mean algorithm is appear after we have the computer. In fact, you find that a lot algorithm, this word is derived from the name of a Perseus mathematician in the 9th century. It's 1,000 years ago. And so-called maybe not the first algorithm, but what you have learned about an algorithm, a well-known algorithm is a Euclidean algorithm, finding the greatest common divisor of two numbers. It's 300 BC. More than 2,300 years ago. people already have thinking, come out the algorithm to solve some problem. And then, algorithm is not just for computer. If you read the textbook, actually algorithm is they define algorithm is a sequence of unambiguous instruction for solving a problem. That means it's not for computer to solve the problem. It's for you to solve the problem. So you need to come out a unambiguous instruction, and then you use the computer. It just realize this unambiguous instruction, and write it in the C programming, in any programming language, and then you give whatever input in the finite amount of times. Computer can help you to get the required output. Similarly, in this well-known textbook, Introduction to Algorithm, Coleman also defined that an algorithm is any well-defined, so it's unambiguous and well-defined computational procedure that takes some value or set of value, input, and procedures some value and set of output. So that means it's like write a function, you have input and output. You have this input, I give you this output. And today you give me this input, tomorrow, you get this output. Tomorrow you repeat the same procedure, same input, exactly the same input. I should give you the same output using the same procedure, computational procedure. So it must be well defined. So summarize, it's like algorithm. First, of course, it must be correctness. You must make sure that you come out the idea, you come out the algorithm must be give you the correct output, and must be correct and consistent. Means that today you give me this input, I follow the instruction, well-defined instruction, go through it, then I get this output. Tomorrow you give me the same input again, I repeat the same procedure, I should get the same and correct output as yesterday I did. So precision, of course, all these instruction imply that you need to be having the consistent output. You expect that your step, your procedure must be well defined and precise. So should not have any word like maybe, roughly, about, better, good, large. This kind of unclear, undefined term. Then and that means everyone can interpret that particular word very different, and end up you can have very different result. Although you have the same algorithm. That means that is not a good algorithm, or that is not the correct algorithm. Another key things you need to take notes is like all these algorithm we discuss, it must be terminate in a finite number of instruction, in finite number of times. That means you cannot have an algorithm trying to run infinite loop and forever you cannot get the final output, or you need to run very very long, like hundreds years, 1,000 years. Well, that is not really a good algorithm. The worst one is, of course, is running the infinite loop. Basically this one, that means forever you won't get the output. Not saying it's correct or not, you not even have the output. So roughly that is what the algorithm about. In short, actually, that's what I want to tell you is that algorithm is not really program. Program is just an instant. For you to realize your idea, your algorithm, and into in computer, and let the computer don't know anything. You teach him, you give him the instruction, he follow your given instruction in certain programming language, he follow it and give you the desired output you want. And that's when today you give me an algorithm, I may not need to use the computer to do it, to solve the problem. Human being also can follow the instruction, the algorithm, to solve the problem. It's just like sometimes certain algorithm is too tedious and time consuming. I need to repeatedly do particular thing again and again, 100 times, 1,000 times, million times. Let computer do the job is better and smart. Computer can 24 hours, 7 days help you to repeatedly do the same thing. They won't feel tired. As long as you provide sufficient power to him, he will keep running and solve the problem for you. That's why we choose computer. That's why we will learn programming to teach computer how to realize the algorithm. So that is what algorithm trying to do. And yeah, so don't misinterpret that between the algorithm and program. Yeah, program is just an instant. So this module, what you have learned is not just for C programming. That means tomorrow you need to write your program due to whatever reason, you need to write it in Python, in C++, in Java. The same algorithm, you also can realize it in this language. It should not be an issue. Yeah, if you know those language, you know this algorithm, you should be able to realize it. Yeah. So for example, very simple example. Yeah, I want to calculate a arithmetic series to sum the number from 1 to n. Yeah. I think everyone should be able to do this. Yeah, you just declare a variable and then run a loop, n iteration. Yeah. In each iteration, you just increase a variable I from 1 to n, and then you add it. At each iteration, you just add the number into the sum. After n iteration, you will get the answer. So this is one very straight one. Your problem is trying to sum the number from 1 to n. Then I just follow the instruction to write. Actually, yeah, there's no, maybe this is a very simple example. Yeah, one key thing, maybe a common mistake is remember to assign 0 to the sum. Yeah, a lot of time people only think that, sum the number from 1 to n, just sum the number 1 to n. Yeah, actually, if you don't assign 0 to the sum, you won't get the right output. Yeah, well, some people are a little bit smart, or they have learned the arithmetic series. They know that, actually there's a formula. Yeah, you try to sum the number from 1 to n, there are n term. Then the first term is 1, the last term is n. So in fact, I already provide you the mathematics revision. You can find out how this thing can, how people derive this particular formula. So n term times the first term is 1, the last term is n, 1 plus n divided by 2. That is the arithmetic series answer. Now, the first algorithm, maybe you also can write it in the recursive way. Yeah, that also can. Yeah, but algorithm 1 and algorithm 2, algorithm 3, they function in terms of complexity, they are the same. I would say, this one run n iteration. This one trying to run, including itself, is an n function call. Yeah, you run n minus 1 recursive call. Then there's one function called total n call, then you get the answer. Each function call is just trying to sum two number. Yeah. This one, each iteration you try to sum so-called two number, also sum plus I. Yeah. So the complexity is the same. But the second one definitely give you the best, just one line. Yeah. One multiplication, one summation, one division, you get the answer. So you can try to write this program and then try bigger and bigger n. Yeah, slowly you will find that the first and third algorithm, maybe third one will be crash first because you may run out of memory soon. Yeah, because you got limited stack memory for you to store so many function call. Yeah, but the second one should be always working. Yeah, because it's just one line. Yeah. So these are the things you're going to learn in this week, how we analyze the algorithm, some simple algorithm. Another typical classic example is the Fibonacci sequence. Yeah, you're trying to find the Fibonacci sequence Fibonacci sequence is basically, you have two first number is 1, 1, then the third term is the first two summation, 1 plus 1, you get 2. The fourth one is the second and third one, sum it up, 1 plus 2, you get 3. Then 5 is come from 2 plus 3. Then 8 is 3 plus 5, you get 8. Then 5 plus 8, you get 13. 13 plus 8, you get 21. And so on and so forth. So the formula is like, you just sum the previous two terms, that is your current term. Yeah. So one approach is using the iterative way. So if it's n equal to 1, n equal to 1 or n equal to 2, you return 1. Otherwise, you are trying to iteratively sum. 1 plus 1, you get 2. Just like what I'm doing just now. 1 plus 1, you get 2. 2 plus 1, you get 3. 3 plus 2, you get 5, and so on and so forth until n term, you get the answer. Yeah. So another way, this is one iterative way. I think when you learn the recursive function, this probably they will cover it. Yeah, it's a very classic recursive function. I mean, you recursively run this function to sum the previous two number. Yeah, you get the current number. Yeah, recursively. Then you get the answer. And in algorithm, in this level and the next one, 2101, we not just want to come out the solution. We always trying to think that, today I got two ideas to solve this problem. I have algorithm 5 and algorithm 4. Which one is better? Which is the better algorithm? This is something you need to think about it. So, of course, I think this level I don't expect that during the don't consider it during the lab test. You only have 1.5 hours. You should trying to find you can solve the problem is more important than you have the best solution. So, but you need to have this kind of mindset. Maybe when you're doing the assignment or in the lab, after you have one solution, you should go and think about it. This solution, is it good enough? Am I be able to think out another better solution? Which one is better? Or even thinking that after you have two solutions, is there any even better solution? In fact, from these two, algorithm 4 and algorithm 5, what do you think? Which one is better? No one respond? Five. Okay, at least someone tell me 5. Okay, good. So if you some people may know. Some people think 4. Okay, 1. Iterative one, yes. I think most of the people think iterative one. Yes. If you observe it carefully, actually the right hand side one, they just run n iteration. If you go and analyze the left hand side one, this one, the complexity, okay, this one we will not cover. We cover in we cover in the 2000 module last time. If you go and study, you will find that actually this one will give you the complexity. You need to run roughly so many iterations. It's a function of this. 1 plus 2 square root 5. I don't know, 2 power to how to write 2 power to n. Should be in this function. Or about 1.618 power to n. So your n increase, actually the computational times is increased quite scary. You can try to write this program, and then you'll find that when your n equal to 100, you'll find that your program basically look like hang there. Should be, if your computer not powerful enough, when n equal to 100, probably you will take half an hour to 1 hour. I didn't try, but you will take quite long times to get the answer. Initially, n equal to 1, n equal to 2, n equal to 3, not an issue. When n equal to 100, n equal to 1000, probably your computer already cannot run. You will just, it won't hang, but your program is still, your computer is keep running to do this calculation. Because they have a lot of redundant step if you analyze it compared to the right hand side. In fact, they are another even better than the algorithm 5 algorithm. Which take logarithmic times can finish. So these are what we trying to think about when you have a solution. I think earlier people trying to have this solution. Yeah, then soon people find that this solution is better than this one. And then people will further think about it. Yeah, whether can have better solution. And again, you'll find that to come out better solution, a lot of time you also need to have some mathematics knowledge. If you don't have the mathematics knowledge, you cannot analyze the problem properly. Of course, not surprising that you can't find an even better solution. Yeah, you only can follow the given question instruction. I tell you this is the formula, you just implement it accordingly only. So that's why, yeah, computer science program or algorithm, yeah, you really need to have some mathematics knowledge. Yeah, it's not just for coding. So problem type wise, we in this module, we in the next few weeks we only can cover about the searching and some graph problem and combinatorial problem. Actually, it's still the graph problem in the topic we cover. Yeah, then sorting, string processing will cover in the next level, 2101. Then geometric problem, numerical problem, probably, yeah, you have to take some mathematics module. I think in our program, it will appear in some maybe computer graphic, maybe in some networking advanced 3000, 4000 module. We will cover a bit here and there. Maybe we don't just talking about that. Sometimes they may not tell you that that is the geometric problem, that is the numerical problem, but they are using it. Yeah. So searching, I think in fact searching you have learned in computational thinking in the first half when you do the linked list, when you search a number, yeah, linear search, sequential search, yeah, it's just trying to give you a key, you're trying to search one by one. Yeah, that's typical searching problem, and that is the typical, yeah, computer science problem. Yeah, when you learn about a database, what database trying to do, of course, is searching some inquiry. Yeah, then we also will cover the hash table. Yeah, in searching, yeah, you will find that compared to linear search, hash table, yeah, can let you find the item faster, retrieve the data from the database faster. Yeah, a lot of real world problem in your daily life. Why computing is, searching is one of the important computing problem. Yeah, a lot of daily life problem, you are searching the answer. You are searching, yeah, all the among the possible solution, yeah, which is the search the answer. Is it, yeah, like Sudoku, you're trying to search, yeah, which number is not, yeah, from 1 to 9, which number is have not been selected horizontally, vertically, and in each grid. Yeah, you are trying to search. And a lot of problem you find that it may not be the main problem, but it very likely is a sub problem. A lot of times, certain sub problem you need to search the possible answer and then find the best or most appropriate solution in the possible search space. Another topic we will cover in this module is the graph problem. I think in the last 2 weeks you have learned about the tree, binary tree. You can think that binary tree is a special case of a graph. And then a graph is a mathematical structure, consists of a collection of vertex and edge. So not surprising, tree is one. Yeah, the one you have learned, tree is got vertex. All these nodes are vertex. Then all these connection are the edge. So tree can consider is a special case of a graph. But graph not limited to tree structure. It can be like what you see at the right hand side. Yeah, each edge can have, can has one, sometimes can be even cell loop. But here we not considered this kind of scenario. Yeah, only one vertex or two vertex associated to it. Yeah, typical graph problem. Yeah, it can be the path finding. You have a maze. You're trying to find the path. Yeah, in the maze. Yeah, that is one of the typical graph problem. Yeah, this thing, yeah, there's a lot of solution, and which is the shorter path. Yeah, probably normally we want to get the shorter path from the start point to the goal. So that involves some algorithm in the graph problem. Yeah, So typical example in your daily life you may see is Google Map. You're trying to search how to go to NTU using the shorter path. Take MRT is faster, driving is faster, or take bus is faster. Yeah. So this, of course, they involve a lot of interface, the system, but behind definitely there's an algorithm for you to calculate the shorter path based on the given information, the path, the travel times, the travel, all the transportation speed and so forth. Provide all this information. How do you find the shortest path to reach the destination? Yeah, this is one we considered, and there are a lot. I think this is just one of the example. Graph is one of the big topic. Yeah, you can easily find that. I think in some mathematics program they even study graph can study 2-3 modules. Yeah, just learning about the graph. Yeah, combinatorial problem is another one to find all the combination, to find all the permutation. Yeah, it's mainly typical. It's like trying to study the arrangement, the pattern, the design, the assignment schedule, the connection, the configuration, all involve the combinatorial problem. Typical example in the cryptography, you want to transfer the information from one end to another end. To do some security, you will do some encoding, and then before you transmit, and then you need to make sure that when the other side, the decoder, always can decode it correctly. So this is like all the combination. When you encode the message, must be able to correctly decode it at the other end. So involve all the combinatorial problem. Of course, not only that. Yeah. Another classic example I trying to cover in the end of of this module in week 12 is the matching problem. Yeah, that is a graph problem, also is a combinatorial problem. So you will find, you have a N worker, you have a M job. Yeah, you need to assign, and each person have different capability to do different job. They may not be able to do all of them, so you need to find the maximum match among the worker and the job. Yeah, so this is a typical assignment schedule. When you are doing your final year project, for example, you need to select 8 project maybe. Then based on our proposed final year project, this is kind of a matching. Everyone will select 8 project, and we have 600 students, 700 students, and everyone will select 8 project. How to do the best? How to find to let everyone assign a project that someone maybe some project is very popular, a lot of people want to select it. Maybe some less popular, very few people select it. How to find the assignment? That is something very challenging. Same thing, our job schedule. All the faculty have different capability to teach a few module, but we can't let everyone how the school assign the duty. That is another matching problem. In our daily life, there's a lot of this kind of matching problem. We need to resolve. That is one combinatorial problem. You will find that actually this also is a graph problem in the later lecture. Another one, so after that you find the solution, maximum matching. Another one is the minimum vertex cover. So you give a graph, you need to locate some vertex which can cover. That means all the other nodes just need one edge connect to this particular vertex. They are all adjacent to this particular vertex. All of them are adjacent. So you need to find the minimum number of vertex which can cover. So-called cover, that means all the other nodes will just adjacent to these 2 red color nodes. So that is another combinatorial. Of course, this is a small example. You try a few times, you can find out the answer. When you have million nodes, to find the minimum vertex cover, or the matching problem now is 3 by 3, three person and 3 job. It's quite easy to resolve. When you have Like what I said, like FYP project selection, you got hundreds of students and hundreds of projects. Yeah, if you really manually to look at it to find the so-called best match, it's very difficult. Sometimes you also need to consider the priority that your first choice must be trying to match your first try first, then your second choice and your third choice, and so on and so forth. And the project also have some requirement, maybe got some requirement there. Yeah, to find the best match, maybe not something so simple. Yeah, then how do we resolve this problem is challenging. Another one is the sorting. Sorting problem, yeah, we'll rearrange. Yeah, I think when you do just now the linear search, you will find that they are not sorted. The data is not sorted. Yeah, sorting is trying to sort out the data. Like last week you learned about binary search tree. Yeah, these are sorted data. Then it will help you to improve your searching time. Yeah, when you search if you have sort out the data, of course, not surprising that you search the item will be easier. And sorting can be in numerical order, can be lexicographical order, or any other form, as long as you're trying to arrange it in certain manner, in certain order. That's so-called sorting. Yeah, typical example to show you is like, for example, I want to find the top 5% student. If I don't sort the data, finding the top 5% is not easy. I need to keep repeatedly compare the number between between students, then I can find out the top 5% student. Another one, for example, I want to give you this number. If it's not sorted, you want to find the median number. You can find that you want to directly find it, maybe not easy. But if you sort the data, you want to find the median, actually you just give me I just need to know the data size. I just find the index in the middle. I already get the answer. So sorting is another quite important and typical problem in computing. A lot of time is this searching and sorting is the sub problem in the real world problem. Yeah, once you sorted the data, a lot of answer become very simple to find. Yeah, and in the sorting, a lot of time we also consider, especially in database, we need to consider the stability, because you may not sort based on one factor, one column. You like Excel sheet, you have multiple column. You need to sort. For example, your name in alphabetical order. Then maybe second column is your age. I need to sort from the youngest to the oldest, for example. Yeah. So-called stability is like if you have the same ages. Let's say I sort the ages. Not surprising, a lot of people having the same ages. After I sort it out, then I go and sort in alphabetical order. Yeah, I should make sure that the age, the order should not change. Imagine those people in the same age should not change the order. Otherwise, you need to repeatedly sort between these two columns forever. Yeah, you cannot get the stable sorting result. Yeah, so this is one of the problem we need to ensure our sorting algorithm is stable, especially in database. And another problem you will cover in 2101 is string processing. Yeah, we want to find the word, this micro in this word. Yeah, so this is a so-called string matching. Typically, every day maybe you have an article, you want to search certain keyword. This is typical string matching. Yeah, another one typically now a lot of people are working on is this COVID-19 virus. Yeah, the genome sequence. Yeah, people need to compare, need to do the matching. Actually, all this genome is formed by ATGC for nucleic acids. Yeah, so they're basically trying to compare. Then if there's any mutation, any things, they're trying to find the best alignment and then detect any segment there's any mutation between two sequence, or trying to matching these two genome, how similar they are, and so on and so forth. A lot of research people working on this. In the end, you'll find that all these are trying to do some string processing. Yeah, to understand the changes of this. Yeah, so computing is trying to help a lot of in many areas to solve a lot of problem. Yeah, a lot of time they're trying to model this into like a string, like a graph problem. Then you find that the problem become very easy to solve. It's just the job a lot of time is very tedious, require a supercomputer to do, because the data is very huge, can be in million. Human being can do it, but maybe computer take 5 days to do it. You take 5 years, 50 years to solve one problem. Yeah, the algorithm is still the same. Just human are not good in doing that job. Yeah, computer are good in repeatedly do this. Yeah, 24 hours, 7 days. Yeah, so this is the application. Another field we not cover is a computational geometry. Yeah, a lot of problem is computational geometry. Here is I introduced to convex hull problem or Delaunay triangulation. Then given you a few points, you're trying to find the smallest convex polygon to contain all the point, all the given point. Yeah, to find this is maybe not easy. Yeah, when you have you got million of point. All this is typically people working in computer graphic. They may need to do. Yeah, Delaunay triangulation also. Yeah, give you a p discrete point in the plane. You need to triangulate them such that no point is in the inside the something like this, having some points still inside the circle of any triangle. Okay, just let you know. This one we will not cover. Another one is typical numerical problem or optimization problem, and it's use a numerical approximation in mathematics analysis. Like maybe you have learned about Newton method, Gaussian elimination. All this is a typical solving problem method we use in engineering and mathematics using mathematical model. Yeah, another popular one is a linear programming. You find that actually later you will find that the matching problem actually is also related to this linear programming. Like you have a lot of constraint. Yeah, the x and y must be within this range subject to and you're trying to optimize it to find the optimum solution of 3x plus 5y. This is so-called all these linear constraint, so-called linear programming. You're trying to find the solution. So this is one of the typical optimization problem. Numerical problem. Well, this is involved in other modules. So just let you know that there are a lot of problem type can be solved by computer, and typically we study all this to solve some real world problem. But all this is, you can think that it's just a sub problem in the real world problem. A big real world problem, you have to find out that there are a lot of this kind of sub problem too. So you need to learn all of them, then you can solve the truly real world problem in the future. And this one actually typically, like I said, is people working in engineering. A lot of engineering area. People, maybe you heard about people working in the operation research. They need to use this optimization problem. I think in engineering, everything is you wouldn't be able to get the so-called best solution in engineering problem. A lot of time you're just trying to optimize it to get the good solution or workable solution. So a lot of time this is something useful. If you are interested, you may need to take some mathematics module. I think our program maybe not cover this thing. And all this is the problem. Then how do you solve them? There are a lot of strategy to solve this problem. Here, like linear search, all this is a kind of like a brute force exhaustive search strategy. And then I think in the binary tree you have learned, you should realize that actually you are trying to divide and conquer. You are using a divide and conquer strategy to divide the problem into a smaller sub-problem. And then each sub-problem are the same, but just the problem size become smaller. The data, the everything will look, is smaller, but the step procedure are still remain the same. Yeah, and then you're trying to solve the smaller sub-problem, and then after that you slowly merge to solving the bigger problem, and then it's so-called divide and conquer. Or sometimes it's a decrease and conquer, means that you may not solve all the sub-problem. After you divide the problem into a few sub-problem, like binary search, you may select one of them and then decrease and reduce some of them. You just simply ignore the other half of it or more. You only solve certain sub-problem only. And then eventually you can solve the problem. And another one, transform and conquer, we will cover after the recess week. One is the algebra expression. What you have learned, maybe the tree balancings you have learned last Monday. I think tree balancing is another one. The current one is not good. The current structure is not good. The current the provide the data or the information they provide to you is very difficult. It can be solved, but very difficult, or your algorithm is very complicated. Then you are trying to transform your information into another form, another way, so that you can solve the problem easier or maybe faster. That is transform and conquer trying to do. And then another one is a greedy strategy, typical. A lot of time, like I said, you won't be able to get the best solution. So you may use a greedy strategy or iterative improvement strategy to get better and better and better solution. Greedy strategy is like, at this I don't know the global, the general solution, but just at this moment, I know that the best decision I can make is choosing the shortest path to move, the shortest step, the nearest target or nearest nodes. I just move to the next, the shortest, nearest, the best, whatever. Just trying to it's a greedy strategy. Just always pick the best at the moment. To solve the problem. Well, sometimes you may not get the best solution, but you get the optimum solution. Because you have no idea at the moment, at the beginning, you have no idea what is the best solution. And if you consider all the possible permutation, combination, then the computational time is you will take too much time to find out the one solution. Not practical. So in engineering, sometimes we have no choice. We want to quickly get the answer. So maybe that is not the best solution, but at least I get a solution. So it's better get 0 marks. At least I get a portion. So that is trying to so-called the greedy strategy. Sometimes it work especially in engineering but I have to say not always. Like the lab test. If your test case is not correct, means not correct. It's not, there's no so-called 50% correct, 50% not correct. This kind of thing is still not correct. So not always work. So you have to, based on your problem you face, to select the right strategy. If you choose the wrong strategy to solve the problem, in the end you may not. Sometimes unfortunately you may not be able to solve the problem, or you may not get the answer you want. The result you want. So iterative improvement is similarly. That means every iteration you just trying to, based on the previous result, trying to further improve, or trying to expose more. After you get one result, you will find out that there's a even better solution from the previous result. You can improve it. You can adjust your previous result to getting closer and closer and closer toward the final optimum solution. So that is so-called iterative. Maybe if you have learned about Newton method is one typical iterative improvement way to find the local minimum or local maximum. Yeah. Again, I said it's local. That means you won't be able to know whether the solution you found is the global minimum or not in the end. Yeah. So these are the different algorithm design strategy. Again, you find that not really need to through the programming. Yeah, sometimes it's in your daily life. Sometimes it's in some mathematics problem. Yeah, you are using this strategy to solve the problem. Yeah, so learning algorithm may not just learn how to code. Yeah, it's another level. You're trying to think how to solve the problem first. Yeah. So, yeah, this is algorithm is not just I have to say computer programming is still important in this module. In this program, yeah, but we are trying to move to another level to learn how to solve the problem through the algorithm, through a very systematic way to solve it. And using different strategy, to solve the problem. And identify the computing problem and then using different strategy to solve each sub problem systematically, and then you can solve the real world problem. So this is the different the step we're trying to do. And if you have go and find the textbook like algorithm, I don't know whether you can see. The book is like 1,000 pages. Any algorithm textbook can easily go to 1,000 pages. So you should not be surprised that this thing is not something simple. We only introduce this module use a few example, a few algorithm, a few problem. Okay, so algorithm may be not something you can learn finish everything in 6 weeks times. A lot of things you need to maybe in 2000 you will learn more, even more. But still not enough one. You will find that still a lot of problem we don't have time to cover everything. So if you're interested, you should trying to get the textbook or read more by your own. Well, assignment, test, quiz will only cover the topic we discussed. Then tutorial mainly is understanding, let you focus on understanding the concept. So practice coding is still need to you yourself go and really code it. So I see in the lab section a lot of people like to go online here and there to find the solution and then appreciate the code. Every day just look at the people answer and then appreciate it. I would say that in the end you will find that especially next week during the lab test, you will realize that doing so you still don't know how to code. If you yourself don't practice weekly, or you wait until last minute to start trying to code a few line code, you're not surprised that during the lab test, you just find that actually you still don't know how to realize the program by your own. So again and again, all this assignment, lab test, lab section, you should need to spend a lot of time to practice. Lecture and tutorial. Lecture is mainly just highlight the concept you need to know. And then tutorial is helping you to clarify your doubt. If you have any problem, at least tutor or the faculty can help you to answer your doubt. Or you can send me an email if you don't really understand certain concept. But in the end, you need to find that this module, you have to invest a lot of time in the lab section or at home to practice how to realize those code. After I give you the idea, after you know the idea, after you understand the idea, how you realize those code. Into a C programming program. Into a program. From an algorithm to a program. This thing we may not be able to. Recommend reading good. I think in the notes we already provide you some textbook for you to study, discuss. Okay, where's my? So notes wise, you go and search. There are a few books. Of course, there are a lot of books, not limited to this. This one. this one, yeah, all, yeah. And also highlight to you, you want to, yeah, there's a lot of animation in my PDF file. I find that you want to run them, you have to use the Acrobat, yeah. Reader should be good enough. You don't need the Acrobat. Yeah, Adobe Reader should be able to run. So these are the few. The more classic is this one. I think everyone study the algorithm. Yeah, definitely they have a book. You can try to visit all the professor, yeah, in our school. Yeah, most of them have this book. Okay, yeah, I think today I will stop here. Wednesday, I will start cover the algorithm analysis. Yeah, I hope this part probably I will cover half of them in Wednesday. Then week 8, we come back, we'll cover the other half. Yeah, probably this is the plan. And then, yeah, and also the advanced data structure. I just give one application to show you how we use the stack, yeah, to solve arithmetic expression in week 8. Yeah, okay. That is today's lecture. Any question you want to ask? Yeah, library all have this book. Yeah, not surprising. Nowadays, no one go to library to. Yeah, I find all this book is always available in the library because no one borrow anymore. Any question? If not, now it's 11:30. So that's it today. Okay, thank you. Bye. Prof, will you release the lab? Tutorial is released already. Tutorial question is already released. Lab, I think I will release in these 2 days. It's almost there. Yeah, I just try to go through it one more round, see anything I need to adjust a bit. Yeah. Then assignment, I probably will trying to release them. Yeah, maybe after your lab quiz. After your lab test, after recess week. Yeah. Coding, that is your, yeah, I can't comment on your personal. But I think one thing, like I said, that this module you have to spend times to practice. You have to spend times to do more practice. If I think it's very different from other modules that, yeah, you maybe attend the lecture, attend the tutorial, or sometimes you're not attending, you just watch like last minute before the test, you quickly go through, watch all the video, yeah, in 2 times speed, 4 times speed. Yeah, some module you can handle, you can, yeah, it's not, it's just like trying to memorize all the theory, all the concept. Yeah, then this approach is working. But when you're talking about courses like need to do programming, need to do mathematics, all this, a lot of time not really that you can just last minute go through all the lecture. Yeah, in fact, I can honestly tell you that this part, the lecture, is just teach you the concept. So you watch the lecture video last minute, you just realize that all these things you don't know how to code. Yeah, in the last minute, yeah, it's too late already. Yeah, so a lot of time here is just you should think that the lecture is like I give you a summarize. Yeah, these are the things you need to know. Yeah, then you should go and trying to practice how to realize. Yeah, I give you this algorithm, how to realize it. Yeah, you really need to think about it, how you yourself go and realize it. I give you the code, actually it become meaningless. You see it, okay, yeah, this is the answer. This is the answer. Yeah, you write a for loop here, and then after that you call the if else statement. Yeah. But you still don't know how to. Give you another question. Yeah, following week you will find that I just turn, I don't need to be very complicated. I just switch the problem into the other way. You will find that you still don't know how to do it, or you trying to go and memorize the solution given in the tutorial, even in the lecture. It's a disaster. You find that programming is so difficult that you need to, if you use this wrong approach, you will find that all this is become very difficult. You memorize them, then you find that another problem, not really, how can you use the solution B to solve the problem A? Yeah. So in the end, I think there's no shortcut. You have to practice, and through your practice to more familiar the C programming. I think a lot of people still not very familiar with the C programming. One thing, the syntax is not, sometimes will mix with the Python. Some people look like mixed with other programming language. Yeah. So this thing, how to debug the program, and a lot of people during the lab session, I can see that, given you the code block, any IDE, but you don't know how to do the debug. In the end, not surprising that the programming is very difficult stuff for you. So but if you learn how to do the debugging, how to fully utilize those program, those IDE compiler to help you to do the debugging, actually this module probably is the only module that, not the only module, there's a few module. Programming module is the only courses can let you, during the test, you still can check your mistake, where is your mistake, how to correct those mistakes. Still got people hint you, there's a compiler hint you that your line 13 got problem, your line 14 got problem, and then you can figure out how to fix them. Other courses, exam, you make the mistake, you submit it, that's it. You have no chance to make any correction during the exam, and not even have anyone will tell you the mistake you have made during the exam. So depend how you learn it. I would say that the learning approach is very different from other courses. Okay. Any question? If not, I will stop the streaming. If you have any question anyway, you still can email me. Hey, where is it? Here. So you can still email me. Okay, you're seeking for any consultation, try not wait until last minute. We have 600 plus students. Last minute you seeking for consultation, you're not surprising that other students will do the same thing. Then I won't be able to help everyone. Okay, goodbye.